Welcome to our 8th learning workshop over acids, bases, and it says gases, but that's a lie. We're not going to do anything with gases. I'm going to take that off. Acids and bases. Okay. So the first thing we want to do is talk about naming and identifying acids and bases and salts. So, first thing, a couple notes on naming acids. So when you're naming acids are, it's helpful to keep in mind, keep in mind that acids are compounds that are like ionic compounds. Can't spell. Except that the positive ion is always H plus. Acids are compounds that are like ionic compounds, except the positive ion is always H plus. So they have a positive ion and a negative ion. Positive ion and negative ion. So here's the deal. If you, when naming, how you name the acid depends on the anion or negatively charged ion. In other words, what is the H plus bonded to?
The cation?
Well, the cation is the positive ion. The cation is the positive ion, and the anion is the negative ion.
Yes, yeah.
So H plus is always the cation with the acids, and the anion is the negatively charged ion. So how the acid is named is dependent upon the anion, the negatively charged ion. So to that extent, if the anion name ends in IDE, highlight there. The name of the acid is hydro something, and this is actually the root name of the anion, ic acid. That's how you name it, hydro something ic acid. And so what's an example? So an example of this would be HBr. Well,
hydrobromide.
Yeah, so Br minus is bromide. So the name is hydrobromic acid.
Oh, I get you. Oh, okay.
So now let me highlight this. Go back to home. Let's do the highlighter. Let's do. So this is the brome. Yeah, brome is the root part of it. So the I becomes it.
Letter? Is your H supposed to be capital letter or small letter?
With regards to the name, it doesn't matter. With regards to the formula, the H has to always be capitalized.
Okay.
But here it doesn't matter.
Okay.
So hydrobromic acid. That's how you name it. So let's see. So a fun way to kind of remember this is like my ride has hydrochloric. So if you have my ride has hydraulics, if you have IDE, then it's going to be an IC ending.
Oh, that's cool.
And that was it. The hydraulics. I'll misspell it on purpose. And then you have the hydro blank X. Let's see. There we go.
I think you should remove the S. So just hydraulic, I see.
Well, yeah, but then it doesn't make sense if you say hydraulics without hydraulic. It's supposed to be plural. My ride has hydraulics. Hydraulics are those things that make the cars go up and down, like kind of like when it bounces up and down, like when it's sitting still.
I know what hydraulic is.
It's something like, I don't know. It's like something that's cool and like, I guess rapper culture or something. I don't know. All right, so
Hydraulics is supposed to be HYDRAU.
yeah, it's actually supposed to be hydraulics. Is actually supposed to be HYDRAU. Yeah, it makes it jump. HYDRAULIC. Technically speaking, it's AU, but I put OU just to emphasize it's hydrobromic.
Right.
acid.
I get you.
Yeah. Okay.
That's
So
so
slight
cool.
misspelling there.
Thank you. That's cool.
Yeah. Now for the other type of naming, if the anion name ends in "-ete", the name of the acid is only the root part of it with an "-ic", acid, and then acid. So let's do an example. An example would be like, say, HNO3. So, did I undo that? No.
Nitrite?
Yeah, so nitrate actually. NO3
Okay, yeah, nitrates, yeah. NO3 minus.
is nitrate. So the name of the acid is nitric acid. So nitrate, once again, this is the root. I'm putting the root in green. There you go. Nitrate becomes nitric acid. So, and actually, let me emphasize this with the gray.
You still add a hydro to it.
You don't add a hydro. So no hydro. If it ends in ATE, then no hydro.
Okay, yep, okay.
And I'll just put a little space here. And just put a little space here too. Ochigo. Okay. So, anion name is this and that. Now, and the kind of a fun way to remember this is I8 acid.
What?
The I8 acid. Ick. Ick.
What if I ate acidic lemon?
Yeah, that. That works too. That works too.
That would work. It's acidic lemons.
So I ate acid, ick. So, and then there's one last one, and this is probably one you may, well, I don't know if your professor will talk about it or not. Sometimes they do, sometimes they don't, but I'll show it to you just in case. If the anion name ends in ite, so, well, actually I'm going to highlight this with the yellow. All right. All right. If it ends in ite, then the name of the acid is only like the root with OUS and then acid. So an example.
Rihanna ends in IT. The name.
So if I had something like this, if I had like H2SO3, actually I don't use that one. Let's do HNO3. NO3. No, HNO2, sorry. Remember, if it has one less oxygen, instead of being called nitrate, it's
That's
called nitrite.
nitrite. Yeah.
Exactly. So this is
So you got nitrous acid.
Exactly, you got it. It's nitrite. So the name of the acid is nitrous acid. So there you go. Nitra is the root
Nitrous acid.
and root, but the ending you get is OUS. So ITE becomes OUS. And a fun way to remember that is Sprite is delicious.
What the?
Sprite is delicious.
When I put termite is delicious.
There you go. That too. That too. Oh my goodness. There we go. Good deal. So these are just a couple examples to show
Sprite
you
is
how to
delicious.
name acids.
Acidic.
And naming acids can be a little bit on the tricky side, but I think
Mine
with
has
these
hydraulic.
tools, it'll make it just a little bit easier. Okay, so looking down here,
Mm-hmm.
first of all, we have to identify if it's an acid, base, or salt. Okay, so if it's an acid, base, or salt. Now we know that an acid is always going to start with an H. So is this an acid, a base, or a salt? What do you think?
Which one?
HCl.
Hydrochloric
Yep.
is an
Is that?
acid.
Yeah, it's an acid. So, and actually, let's go through here and let's just identify them all real quick. What about H2S? Is that an acid or no?
Which one?
H2S.
Sulfate? No, that's not
Well,
sulfate.
don't worry about the name. Is it an acid or no?
Acid.
It is an acid. And what about H2SO4? Is that an acid?
Acid.
Yep, it is indeed. And what about H3? What about calcium chloride? What about CaCl2? Is that an acid or no?
Acid.
Nope, that's not an acid.
Mm.
There's no H. Remember, for it to be an acid,
Oh,
it has to have an H plus. So
that's a
no
salt.
acid. What about, yeah, so this would be a salt. It's an ionic compound. So this is a salt. What about H3PO4? Acid
Acid.
or, okay, so that's an acid. What about Na2SO4? What's that?
Salt.
Salt.
Mm-hmm.
And what about H2CO3?
Acid.
Mm-hmm. And what about NH4OH?
Salt.
Oh. Now this is tricky. Okay, so
No, that's a base.
a base is any ionic compound that has OH minus in it. Strong bases and weak bases, but a base, if it has OH minus in it, it's going to be a base. So with this, what do you think? Acid, base, or
It's a
salt?
base. It's a
It's a
base.
base. So if anything that's OH in it, so NaOH, so like for example, NaOH, KOH, LiOH, SrOH2, I mean, any of those, anything that has OH in it, it's going to be a base. Okay?
Mm-hmm.
With the, I mean, as long as it's an ionic compound, if it has OH in it, it's going to be a base.
Yeah, but you didn't tell us about, you didn't say anything about salts now. I think you should define salts for us too.
A salt is like literally salt is literally any ionic compound.
Okay.
Technically speaking, even this is, technically speaking, this is also a salt. A salt is just another name for an ionic compound.
Mm.
A salt is just another name for ionic compound. NH4 is a polyatomic ion that acts like a metal. So since it's a polyatomic ion that acts like a metal, this is still an ionic compound. Usually ionic compounds have metals and nonmetals, but in this case, it's a polyatomic ion that acts like a metal, so it's still considered a metal for ionic compound purposes. All right, so let's name these. Okay, so what is HCl?
Hydrochloric.
Yeah, hydrochloric acid, because it's chloride, and my ride has hydraulics, so hydrochloric acid. And what about H2S?
I
This is a little bit tricky.
sulfide. Sulfide.
Sulfide,
Hydrosulfide.
not hydrosulfide. Remember, my ride has hydraulics, so it's sulfide becomes hydro. Now so I will make a note here. Normally, the root for sulfur and phosphide /8 phosphate sulfate.
Let me write. You said for sulfide.
For sulfides and sulfate and phosphate, use the root sulfur and phosphor. So the root for sulfide and sulfate is sulfur. So in other words, normally you might think, well, it's sulfide, so I just call this hydrosulfic acid. But the problem is the root for sulfide is not it's sulfur. So I have to say hydrosulfuric acid. It's one of those little confusing ones, but that's hydrosulfuric acid. If it was H3P, you could call it hydrophosphoric acid. So it's phosphide. What about this one? Next one is H2SO4. What's that one going to be?
Sulfuric.
Sulfuric acid. Very good. Sulfuric acid.
How are you pronouncing it? Pronounce that again.
Sulfuric.
Not sulfuric.
You could say sulfuric. It's just not how it's pronounced, I guess.
Calcium
But
chloride. Calcium
usually sulfuric. Yeah.
calcium chloride.
And then of course, you already kind of indicated what the name of this one was. What's the name of CaCl2?
Calcium chloric acid.
Calcium what?
Chloric.
Not calcium chloric. I think Frank's got it. But not that is not table salt. That is not sodium chloride would be table salt. You would not want to yeah. You would not want to season your food with that one.
Now,
It's not poison,
sodium.
but it's not going to taste the same.
This
Let me
one
tell you.
looks like a bicarbonate soda.
No,
No,
that
no, no,
bicarbonate.
no, no. Baking soda is sodium. No, no.
Yeah, it's a
Calcium.
baking soda. Yeah, is NaHCO3.
Mhm. It's
So
calcium chloric, right?
calcium chloride. Just calcium
Chloric.
chloride. Don't,
IgE becomes IC, right? Is that not what you said?
no, not with the salt. With the salt, you just name it like salt. You just name it like an ionic compound. The only time you get, yeah, the only time you get the IC ending is with acid. Don't start putting ICs on everything.
Oh. So this becomes a chloride.
Yeah, exactly.
Oh, let me keep a note then for salt, right?
Yeah, because salts you just name like ionic compounds, and remember with an ionic compound, if for the second element, the for the nonmetal ion, if it's just an element, you just change the ending to IDE, like sodium chloride or sodium oxide or magnesium phosphide or something
So
like
you do
that.
not add I, ick, or whatever.
Yeah, you
Okay.
don't have the ick, ite, us, anything
Okay,
like
makes
that.
sense.
No.
Okay. So calcium chloride. Then the other one is PO4 is phosphoric.
Yeah, so PO4 is phosphate, so the name of the acid would be
Phosphoric.
phosphoric acid. Very good. Phosphoric acid. And
The other one is
if you're British, you might add like a. Oh, no, that's not how you do it. Anyway, I don't care.
sodium sodium uh, sulfate.
All right. Sodium sulfate. Very good. Yeah, this is a non. This is a salt. It's not an acid or base. It's just going to be named like an ionic compound. Sodium sulfate.
CO3 is carbonate. Carbonate is carbonic acid.
Carbonic. Yeah, carbonate. So carbonic acid. Very good. And then what is NH4 called? Do you remember the name of that polyatomic ion?
I know this one is hydroxide. Then this
Mm-hmm.
one is mm,
NH4 has a special name. Do you remember what it is?
it is acetate. No, ammonia. Ammonia.
Uh, ammonium. Very
Ammonia.
good. Ammonium.
Okay.
NH4 is ammonium.
Ammonia.
NH3 is
Yeah.
ammonia.
Yeah. Ammonium. That's all.
Hydro
Hydroxide.
yeah, ammonium hydroxide.
Mm-hmm.
Now, interestingly speaking, because bases are also salts in most cases, I mean, okay, so there are nitrogenous bases, which we're not going to deal with. That's more kind of an organic chemistry thing. But for the bases that you're going to learn about, the bases that are also salts, um, you just name them the same way you would an ionic compound. So bases and salts are basically named the same. They're both named just like an ionic compound. The only difference is that bases, which are also salts in this case, simply have a hydroxide on them instead of some other anion. And then acids you can tell because they have an H plus at the beginning. All right, cool. Now, the only other thing is we want to probably identify the acids and bases as strong or weak. So there's a list of strong acids, and a lot of times professors will make you memorize these. You have to memorize the strong acids. Now, I don't know if your professor will make you memorize them or not, but I'm going to list them out for you here.
Okay,
So
perfect.
HCl, HBr, HI, HNO3, HClO3, HClO4, and H2SO4. These are the these are rather the 7, sorry, can't count today. These are the 7 strong acids. Okay. There's also strong bases. And the strong bases are your soluble metal hydroxide. Any other metal hydroxide is going to be a weak base, but your strong bases are going to be your soluble metal hydroxides. So, what are the soluble metal hydroxides? So that would be LiOH, lithium hydroxide, NaOH, sodium hydroxide, KOH, and technically speaking, CSOH is, and rubidium hydroxide, RbOH. But the truth is, rubidium and cesium are pretty rare elements, so you really don't see those come around a whole lot. Rubidium hydroxide, cesium hydroxide, technically speaking, francium hydroxide, but you'll never see francium hydroxide because francium doesn't exist for longer than a few microseconds. It's such a super radioactive, unstable compound that as soon as it's formed, it like decays almost instantly. So nobody has ever actually seen with their eyes a sample of francium. It's something that's been detected, but it's not, yeah. And so you also have, and now calcium, now magnesium hydroxide is insoluble, so that's not a strong base, but calcium hydroxide is considered a strong base. It's mostly soluble, and then you also have barium hydroxide, strontium hydroxide. Oh wait, whoops. Strontium hydroxide, barium hydroxide, and technically speaking, radium hydroxide, but once again, radium is kind of rare, so you don't really see it around too much, honestly. And typically won't have ever work with it. It is radioactive after all. But your first two columns in the periodic table, those first two columns, the alkali metals and the alkaline earth metals, those hydroxides are strong bases, essentially, with the exception of magnesium. Cool. So that means
Say that again. In the
say that
periodic
again.
Mm-hmm.
So I'll just put it right here. Basically, no pun intended. Basically, get it? Sorry.
Oh,
Sorry, that was really bad. All right, the first two columns on the periodic table, except for MgOH2. That's the only exception, really. Well, and also beryllium. I guess BeOH2. Is that even a compound? I don't know. Huh. I don't know. I'm having issues. Can you tell?
No.
All right, so except for barium hydroxide and beryllium hydroxide and magnesium hydroxide, all other bases, all other those first two columns are strong bases when they have hydroxide with them. Okay, so hydrochloric acid, strong, weak. What do you think?
Strong.
Yep, that's a strong acid. What about hydrosulfuric acid?
Strong.
No.
Hmm?
H2S is not on this list down here. It's not on that list.
Oh, okay, it's weak then.
Yeah, it's weak. Yeah, there's only 7 strong acids, but there's millions of weak acids. So just memorize the 7. It'll be easier. Anything that's not strong is weak. What about sulfuric acid? Strong or weak?
Strong.
Strong.
No, yeah, strong.
Yeah, strong. Sulfuric acid, H2SO4, that's on there. And this is not applicable because it is a salt. What about phosphoric acid? Strong or weak?
Phosphoric, weak.
Weak. Weak. That's weak. All right. All right. And this, of course, not applicable. What about carbonic acid? Strong or weak?
H2C, weak.
Weak. And what about NH408? Strong or weak?
Not a strong.
No, it's not one of these strong based on the first 2 metal hydroxides. Not the first 2 columns.
Oh,
Yeah. Those nitrogenous bases, those bases that contain nitrogen, of which this would kind of be considered one, those are always weak bases. So, weak base. So this is a weak base. All the others were weak acids. Okay, cool. So, what are the 5 properties of acids and bases? Well, I'll
acids and
actually just go. I'll go over. Well, you can maybe tell
I
me a
think
couple.
acids have ions in them.
Well, but these are properties. So
Okay.
if you didn't know the chemical formula, if you were just see a sample of something, and all you could do is like, test it and test it, taste it, mix it with other things, what would tell you? What would tell you that this is an acid? What are the key features of an acid? You kind of mentioned one of them earlier. Ooh, I have some answers. I have some answers. Bases are slippery. Very good. Absolutely, Frank. Bases are slippery. They feel slippery. And the reason they feel slippery is because they're melting your skin.
Yeah, you said that before.
Skin, yep. You. Okay. What else is a property of an acid? Well, the acids are actually not bitter.
Acid can burn.
Yeah, oh, acids burn. Yep, that is one property of acids. Um, acids burn when touched. Feel the burn or not.
Is that the same as corrosive?
Yeah, they're corrosive. So acids burn when touched. They're corrosive. In fact, actually, both acids and bases are corrosive. That's actually good. They're both acids and bases are corrosive, but they're corrosive in different ways. Bases are more corrosive against organic matter, and acids tend to be more corrosive against metals and things like that. But they can also be corrosive towards organic matter and things like that as well. Um, so they're both corrosive. Which is bitter? Because acids aren't bitter. What do acids taste like?
Bitter. Are you supposed to taste an acid? I can't.
You taste acids all the time. Vinegar is an acid.
It's bitter. It tastes sour.
Yeah, vinegar doesn't taste bitter, it tastes sour. Yeah, and lemons are also taste sour. Yeah, acids taste sour. And in fact, any sour flavor that you ever have, like, or if you ever eaten a sour candy, they use malic acid or fumaric acid or citric acid or vitamin C is ascorbic acid. So yeah, acids taste sour. And honestly, a lot of them, some of them are vital nutrients, and a lot of them give food a really good flavor. I like tart flavors. Um, but what do bases taste like?
Bitter.
Bitter, yeah. This is bases taste bitter, unpleasant. Think of like soap. you tasted soap, it'd be yucky.
How would you taste soap? Hello.
Or if you were ever a bad girl and you like said wicked words to your mom, she might have washed out your mouth with soap, right?
No.
Well, yeah, Linda's a good girl. She wouldn't do that.
If my mother was to wash my mouth with soap, she'll go to jail.
That's actually a classic thing that you used to do. Like if you swear, your mom would wash your mouth out with soap here. And it's just like it'd be basically like it would be the punishment for swearing and saying bad words.
When I was growing up, the punishment in our house is my mom tells you to kneel down or to do frog jump or something. That's that's
Yeah, now kids just eat Tide Pods.
no,
Yeah, no, please don't.
that's poisonous.
Yes, we don't- we don't need to worry about poisoning our kids. They do it themselves. No,
Yeah, funny.
what? So what are the other
Would
what are
I
the
say
other
acid?
properties?
Acids? Do they look acids clear? Do they look clear?
So well, I mean, acids can be actually all uh, acids can be colored or clear, and the same thing with bases. Although bases, I guess, usually kind of have more of a milky look to them. But um,
Hmm.
the other ones you might not get as easily. But for example, one of the properties is acid. You can tell because it neutralizes a base. It neutralizes bases. So like baking
Oh,
soda.
bases neutralize acids. Hello.
Yeah. Ah.
Uh-uh.
So yeah.
How can an acid neutralize bases now?
Yeah. Acids neutralize bases, and bases neutralize acids. Exactly.
Oh,
And acids like vinegar or other acids. Usually, like when you want to use an acid to neutralize a base, usually if you're neutralizing a strong acid, you'll use baking soda. If you use a neutralizing a strong base, you'll use vinegar. Um, Another thing is that
baking soda is baking soda an acid? No,
baking soda is a base.
it's a base now. What about vinegar? Is an acid.
Yep, neutralizes a base like baking soda. Neutralize an acid like vinegar. Um, so, and then another one that they do is they turn litmus paper red. And that's something you're going to be responsible for knowing for your lab exam. That acids turn litmus paper red, and bases turn litmus paper what?
Blue. I
And
knew that when I was in high school.
mm-hmm, I'm going to add just one more because there's one more important thing as far as properties of acids and bases. Acids also um, will uh, they will be clear in the presence of phenolphthalein. And phenolphthalein is kind of an ungodly name. Phenolphthalein is a indicator that helps to decide, or it helps you determine if something is basic or acidic. Um, and bases turn.
Why did you say it's an ungodly name? What's that? I didn't
Oh,
get that.
it's just because it's really hard to spell. Phenolphthalein. Let me look at that name. Phenol. Chthalein. Come on.
What is phenolphthalein? What is that? What is that?
It's a reagent. It's an indicator. It's an indicator that can help you determine if you have an acid or a base. It's a
Oh,
very
indicator.
common,
Okay, I want to write it. Hold on. Indicator,
yeah, it's an
acid,
indicator. Mhm.
or
It's
basis,
also an
right?
extreme, yeah, it's also an extremely powerful laxative.
I know phenol. Phenol. Phenol is very powerful, right?
Well, phenol is an entirely different thing. Phenol
No.
is a derivative of benzene. Ooh, I think phenol might even be a carcinogen. I'm not sure.
Hmm?
I said I think phenol might be a carcinogen. I'm not sure.
I think so too.
Yeah. All right. So now we got our properties of acids and properties of bases. We are good to go. Now let's look at the Bronsted-Lowry definition of acids and bases. And I want to do some pH calculations with you too, but it's really important to understand what an acid and what a base is with regards to the different definitions. So I'm going to go ahead, before I even jump into this, I want to give you a couple different definitions of acids and bases. So there's the Arrhenius definition. So the Arrhenius acid, that is any substance that produces H plus ions when dissolved in water. Any substance that produces H plus ions when dissolved in water. And Arrhenius base any substance that produces OH minus ions when dissolved in water. Okay? Secondly, you have your Bronsted-Lowry base. Bronsted-Lowry acids, rather. And a Bronsted-Lowry acid is a proton donor. And a proton, by a proton means an H plus. An H plus donor. A compound that, in other words, it's a compound that gives away a hydrogen ion in a chemical reaction. Notice that in a Bronsted-Lowry definition is always tied to a chemical reaction. You can't really think of an acid isolated from chemical reaction. And then likewise, Bronsted-Lowry base is a proton acceptor, H plus, any substance that accepts a hydrogen in a chemical reaction.
This is the receptor.
An acceptor, sorry, accept. Compound that accepts or receives a hydrogen ion in a chemical reaction. So now that we have these definitions, I'm going to bold them, make them look fancy, kind of, because I like to be fancy. Don't you like to be fancy? I like to be fancy. Everybody likes to be fancy. Okay, so let's look at this compound here. I see this compound. I see the H2O, the H3O plus, and C2H3O2. So in this case, what you might notice, so your acid and base must always be reactants, okay? So your acid and base must always be reactants. And so if I'm looking at which one of these two is an acid and which one is the base, okay, we'll do the Bronsted-Lowry definition, is the HC2H3O2, is that donating to the water? Or is the water donating a hydrogen to the HC2H3O2?
The water is donating.
Well, if the water is donating, if the water gives away a hydrogen, wouldn't it have less hydrogen on the other side over here?
Is that not a less hydrogen? Okay,
So
H3,
if
no.
if, if water if water gave a hydrogen away to
Mm.
the HC2, wouldn't it only have one hydrogen instead of three?
Because you already have hydrogen in what you are adding hydrogen to again.
Yeah, so which one is gaining hydrogen? Which one is getting more hydrogen, the H2O or the
The
H2?
water that's gaining more hydrogen.
So the water is gaining the hydrogen, it's accepting the hydrogen.
Mm.
So the water is accepting the hydrogen, it's gaining the hydrogen. So the hydrogen goes from the acetic acid to the water.
Mm-hmm.
And because of that, that means that this is your acid. This is your proton donor. And water, since it receives the hydrogen, this is
Mm-hmm.
your base, your proton acceptor. Now on the other side, we have conjugate acids and conjugate bases. And what that means is, that means if the reaction was going to go in reverse, in other words, if you made it so that the reaction went the other way, if it went this way, which one is giving to which? Is this H3O plus giving to the C2H3O2, or is the C2H3O2 giving a hydrogen to the water, or to the H3O plus? Which one is losing a hydrogen if we
No,
go
the
backwards?
H3O plus is a base. Then the other one is an acid.
No, actually, that's not quite right. See, if you look at what if this is going backwards, H3O plus goes to H2O. If this reaction goes backwards, H3O plus goes to H2O. Has it gained or lost a hydrogen?
It loses.
It lost a hydrogen. So this was a loss. It's a proton loser, a proton donor. It gave up its hydrogen. So this it's an acid. It donates the hydrogen, but it's not a reactant. So we don't call it just an acid. We have to call it a conjugate. And actually, let me go ahead and erase that so I can write the full
Ooh, I'm
term.
confused.
This is a little bit confusing. I'm not going to lie. So that's why we're going to do some practice over it. But this is the conjugate. Conjugate. Conjugate acid.
Why is it called
And
conjugate?
because it's basically it's the acid for the reverse reaction. It's the acid for the reverse reaction. It's not the acid for the forward reaction. If it's the acid for the forward reaction, we just call it an acid. If it's an acid for the reverse reaction, we call it a conjugate acid, whereas this is the conjugate base. So this one doesn't give to the HCl plus, so we're going to erase that. Okay, does that make sense? Going forward, the HC2H3O2 donates a hydrogen to H2O, and that's why it causes H2O to become H3O plus. And since it's a proton donor, it's a Bronsted-Lowry acid. The base, the water, accepts the hydrogen, so that's the Bronsted-Lowry base. And then
What's that?
if the H3O plus will donate a hydrogen to the C2H3O2 minus, and so that's the conjugate acid in the reverse reaction. And the acetate ion is going to accept the hydrogen, so that's the conjugate base in the reverse reaction. All right. So let's go ahead and do another one. Let's do the next one. I'm looking at these guys down here. SO3, HCl. Which one of those is your acid? Which one is donating a hydrogen?
The HCl is donating a hydrogen to the SO2.
Exactly. HCl is donating a hydrogen, so that means your HCl is your what?
The HCl is the acid.
This is your acid. And that means the SO3 2 minus is your what?
The base.
The base. Now, if the reaction goes in reverse, which one donates the hydrogen?
The Cl donates the no.
Yeah,
Yeah, the
Cl
Cl
minus.
donates the hydrogen.
Well, the Cl doesn't have a hydrogen to donate.
It doesn't have a hydrogen. So the HSO3 donates the hydrogen, while the other one is the base, the Cl.
So yeah, this is going to be your conjugate acid. This is your conjugate acid. And I'll just abbreviate it CONG, conjugate acid. And this is going to be your conjugate base. All right. Very good, because in this case, this donates the hydrogen to the Cl minus in the reverse reaction, which would cause it to become HCl. In the forward reaction, I'll draw this arrow as red over here, and then I'll draw this arrow, the forward arrow is blue. For the forward reaction, HCl donates the hydrogen to this one. That's why it's the acid. So I'm going to go ahead and give you a shot at doing number 3. Which one is the acid for number 3?
HNO2.
Very good, yeah. This is the acid because if you look on the other side, you see that NO2 minus is by itself. So this is HNO2, so it must have, to get by itself of NO2 minus, it must have donated its hydrogen to the NH3. And that means that the NH3, it must be your
Base.
base. For the reverse reaction,
The NH of the conjugate acid,
yeah, this is your conjugate acid.
and the other one is the conjugate base.
Uh-huh.
How you drawing that arrow? I don't understand how you drew that arrow.
What arrow?
One in the arrows in the middle.
Oh, I was just indicating like this reaction goes both forwards and backwards.
Okay.
The forward reaction I indicated in blue because that's what happens when the HNO2 here donates a hydrogen to the NH3. That reaction goes forward and you get the NH4 plus and NO2 minus. However, when NH4 plus donates to NO2 minus, then the reaction goes backwards and you get the NH3 and HNO2. This is an equilibrium. They're both happening. The forward and the reverse reaction are both happening. Okay.
Okay.
Let me show you a little cheat. And I could have showed you this at the beginning, but I wanted you to understand it first. But this is kind of like a cheap cheating way to do this and make it easier for yourself. So, NH4, what compound is most similar to NH4 on the product side?
NH3. That's the base. Those are the base.
So which one has more hydrogen?
It's NH4 plus.
So that's your acid.
Oh.
And that means the NH3 has to be your conjugate base. So the compounds that are similar to one another have opposite identities.
Hmm.
The NH4 is the acid, then NH3 is the conjugate base. If I look at CO3 and HCO3, which one has more hydrogen? HCO3, so that makes this the
Yeah.
acid.
Said. Oh, I see.
But because this is a product, it's not an acid, it's a conjugate acid. And that would make the CO3 the base.
I
So
get you.
if you compare similar items, one on each side, whichever one has more hydrogen is going to be your acid, and the other one's going to be the base. Reactants are always acid and base. Conjugates are always, the conjugates are always your products.
Okay.
Does that make it a little easier?
Okay.
What do you think, Frank? Does that help? Does this make sense?
It does.
Frank, but are you still with us? Yeah, 100% of the time. You're comparing the similar items on both sides. Whichever one has more hydrogen is the acid, 100% of the time. Just got to keep in mind that the reactants are always your acid and base, and your products are always your conjugate acid and conjugate base. Yeah, no problem. That's a good point. Sometimes those tricks don't always work 100% of the time, but in this case it does.
We're not
Okay.
done now. We're not done with that one. The last
What
one. So that
you want
SO4.
to? Yeah, you want to go ahead and try the last one? Yeah, go ahead and try the last one. That's cool.
Okay. The SO4 and the HSO4. The SO4 will be the base,
Uh-huh.
and then the other one will be the HSO4 will be the acid.
Just the acid, or is it a
The conjugate acid, sorry.
conjugate acid? There you go.
Yeah. Then the HCl will be the acid,
Uh-huh.
while the other is the conjugate base.
Yep.
Hmm.
There you go. Very good. I think you guys got this. So, um, let's dip into pH calculations, and if we have time, we'll go back to neutralization equations. So with the pH calculation, I'm going to stop writing for the moment. Okay. With the pH calculations, there's a couple of formulas that you need to be aware of. Okay, let me see. Insert equation. So the first equation that's really central for you to know is the equilibrium of water equations, Kw. So Kw equals the concentration. Kw is equal to the concentration of, I'll just keep it simple, H plus times OH minus.
What kind of this thing are you using? I'm seeing where you're typing them from. Where is this? Is that on Microsoft Word also?
Yeah, this is my software document. Now, alternatively, now in Kw, here's the thing. Kw is always equal to the same amount, well, at 25 degrees Celsius. But for your purposes, Kw is constant. It's always pretty much equal to the same amount. It's 1.0 times 10 to the negative 14. 1.0 times 10 to the negative 14. Alternatively, sometimes what you'll see is that sometimes you'll see this written like this. Instead of being H plus, it'll be written as H3O plus. Now the truth is, H3O plus is more accurate to what's really present in the solution. However, H plus is kind of a shorthand way that chemists sometimes like to use. So H plus, H3O plus, they're used interchangeably. Those two things are basically the same. Yeah, the H3O plus and H plus are basically the same thing. So don't worry about if you see one or the other. You can use either. The other important equation that your professor is going to likely expect you to know is the pH equation, and that would be that the pH is equal to the negative log of the H plus or H3O plus concentration. You can think of pH as standing for power of hydrogen, because that's what the negative log gives you. So logarithms give you the power. So negative log of H plus, that's going to be your pH. Now bump that up just a little bit. So those are your two big equations, and from those you can pretty much solve for any of these. So like for example, the first question says, what is the OH concentration of a solution that has an H3O plus concentration of 1.25 times 10 to the negative fifth? Well, for something like that, what you can do is you recognize, okay, I need to find OH, and I'm given H3O plus. So what equation should I use here?
The 10 times minus 14.
Yeah, I'm going to use this one. So I'll go ahead and copy this equation. I'll paste it right here. I'm going to use this one. Now it gives me my H3O plus concentrations 1.25 times 10 to the negative fifth. So I'll substitute that in here for the H3O plus. And then all I have to do is solve for the OH minus. To solve for the OH minus, I can divide both sides by 1.25 times 10 to the negative fifth. But if I do it on that side, I have to do it on this side as well. And this will cause the H3O plus, to cancel out. And then if I calculate that, what do I get for my answer?
10 raised to the power minus 14.
Yeah, so 1.0 times 10 to the negative 14th divided by 1.25 times 10 to the negative fifth. Now, one easy way to do this is to go ahead and to use your, if your calculator has a EE button on it, you can just put 1.0 EE negative 14 divided by 1.25 EE negative 5.
Divided by what?
1.25 EE negative 5.
How do you change that to 5? Because when you put the EE, it shows minus 1. So how do you not change that to 5?
I'm not sure if you're hitting, is it two capital E's?
Mm-hmm.
I mean, the other way to do it is just type in 1.0 times 10 to the raised to the power of negative 14 divided by.
No, I wanted you to tell me, because I've been having that problem. That's how do you change it? Because it shows x minus 1, which is the EE. How do you change it to minus 5 or minus 8 or minus 10? How do you do that?
Well, no. Okay, so if so, it's yours says x to the negative 1, and then above it says EE.
Mm-hmm.
So you have to hit the second function,
Oh,
So you can't
okay.
just hit that. Yeah, you have to hit the second function. So it should be 1.0 second EE divided by 1.25 second EE
Say wait,
negative.
hold on. Please, I want you to help me. Say it again. 1.0 times second
No,
function.
well, not times, but 1.0 second function
Mm-hmm.
EE
Mm-hmm.
and then negative 14.
Negative minus 14. Mm-hmm.
Yeah, and then divided by 1.25 second function EE
Mm-hmm.
negative 5.
Oh, I see. Oh,
And
you say
what do you get?
it's just syntax error.
What calculator do you have?
TI 30x 2s. Roman
Okay,
figure 2x.
TI 30X
TI 30x. Roman figure
2S,
2s.
TI 30X 2S. Okay, so I see it. And that's going to be molarity for that
My
answer.
polarity, my.
Ooh, yeah, Frank, if you got 8 times 10 to the negative 18th, what you did was
You add one.
when you divide by a number in scientific notation, you must put it in parentheses. So that 1.25 times 10 to the negative fifth, you did not put that in parentheses because if you don't put it in parentheses, what it does is it only divides by the 1.25, but then it multiplies by 10 to the negative fifth, and that will give you that 10 to the negative 18th that you got there. Yeah, so just watch for that.
For me, the way I get it is that what I do is that because my calculator will not do it. So what I do is that after you divide, right, when it gives you whatever notation, you minus on your own and then you add one to it. You get it. It worked for
Well,
me though.
your calculator will do it. You're just not putting it in right. Now,
Yeah, I think
honestly,
so. I think I'm not putting it right. I don't know what to do.
well, okay, so with your calculator, you should literally put 1.0
Mhm.
second,
Mhm.
and then that x to the negative 1, which has the little EE above it,
Mhm.
and then negative 14. And then divide that, hit divide, and then do 1.25 second.
Oh, you said negative, so it's just second function EE minus
Uh,
14. Mm?
yeah, as a second function, and then you put the EE, and then you
Mm.
do the minus, and then minus 14. But you have
Mm.
to not, you have not the minus sign. You have to do the little negative sign, the one that's on the bottom, the white key on the bottom left or bottom right
Oh,
rather.
that's where I'm making a mistake. Okay, okay, okay. I get you now. Okay, so I don't need to put this. I'm not supposed to put this other. I'm supposed to put this other one. Oh, I got it now. Okay.
Yeah. So go
Huh.
ahead, try put that into your calculator, see if that works.
Yeah, that's what I'm done. Divided by 1.25 second function E, right?
Yep.
E
Yeah, negative
minus
5. Yeah.
5. I got it. It's 8, but it says 8 times 10 raised to power minus 10. That's what it told me.
Yeah, I guess it is.
It's 10, not
It,
minus 9. It's 10.
yeah, yeah, it is. You're
It's
right.
10. It's
It
10.
is
It's
minus
correct.
10. That is correct. That's correct.
Yeah.
Okay, good.
Hey, I finally know how to operate this thing.
Well, and I know, like, and I apologize, Frank. I know it's taken a little bit of time, but it is so important for you to be able to know how to operate your calculator because, I
Right.
mean, like, that's what you're going to use. I mean, you can know how to do the problem all day long, but if you can't use the calculator to actually get the answer, I mean, you're stuck. So,
Oh, thank God. What is the pH of a solution?
okay. So I'm going to go through these with you relatively quickly because we're running out of time a little bit. Um, so, so for this one, it says, what is the pH of a solution where OH minus is 2.5 times 10 to the negative 9? Well, the problem with this question is we're asked for the pH, so we do have to use this. We do have to use pH is equal to negative log of H plus, but we don't have the H plus, do we? What do we
Hmm?
have?
You say what?
We don't have, so we need to get the pH, which is negative log of the H plus, but we don't have the H plus, do we? And Frank said no. That's right. What do we have?
We have OH minus.
OH minus. So we have to use the OH minus to solve for the H plus. And to do that, we need to use this bad boy right here. So we're going to do a similar problem to the one that we just did. The difference is that instead of the previous one, we were given the H3O plus. In this case, we're actually given the OH minus. So I'm going to take my OH minus and substitute it in here. And then I'm going to go ahead and divide both of these by 2.5 times 10 to the negative 9.
It's not the same thing we just did just now.
It's similar, but not exactly the same thing. In this case, we're solving for H plus, and the previous one, we are solving for OH minus. So I'm going to go ahead and divide both sides by 2.5 times 10 to the negative 9. That's going to cause me to cancel out this here. And then I'm going to get my answer.
It looks like the same thing, though.
It's the same type of problem. Yes, it is. What is my H plus going to be then?
Is it 1.25 or 2.5? Oh, 2.5.
Mm-hmm.
Minus 9, right?
So
0.0000 0.123454 0.000004. That's 4.0 times 10 raised to power minus 1, 2, 3, 4, 5, 6.
Now you can switch it to scientific notation by hitting the second psi engineering thing. So the little button, see that button? There's a button on the top that says SCI/ENG. You can switch it to scientific notation mode if you want. But yeah,
How do you change it? I don't see it. Where do you, oh. Okay, so what do you press there? DEGRAD, GRD.
Well, you don't want the DRG one. You have to hit the second function and then hit it, and then you can switch to scientific, SCI.
Oh, okay, I didn't get that. I should go back.
Yeah, I think so. Well, okay, yeah. So yeah, you have to hit the second function and then hit the DRG button.
The what one? DEG or GRD?
The DRG, yeah. The second DRG, and then you select SCI.
No, I don't have DRG. I have GRD. I have DEG, RAD, and GRD.
No, that's the wrong thing. Hit clear.
Clear.
And then do second function, and then hit that same button.
Oh, okay. SCI. I've seen SCI. So I click SCI, right?
Yeah, SCI. That'll get your scientific notation.
How do I click? How do I say okay in that one?
And
I don't know.
Just hit clear.
Hit clear.
Or you hit enter.
Yeah. Which okay, enter. Okay, I got that now. So you said I should divide again, right? 1.
Yeah, that's fine. It's 4.0 times 10 to the negative 6. And that's molarity. Now that I have the H plus concentration, now I can calculate the pH. So I'll do the pH, and it's going to be...
But please, how do I return this thing back to the English?
It's not English, that's engineering.
So how do I return it used to be?
In addition to the scientific and the ENG, there should be a one that I think it's FLO. Choose that one.
Yeah. Is that the normal one?
That's float. Yeah, that's the normal one.
Okay, thank you. Okay,
so then basically I'll calculate the pH by putting the negative log of the H plus concentration. So with your calculator, you would hit negative, the log button, and then you enter in the 4.0 E negative 6. Or 4.0 times 10 to the negative 6.
Okay, so let's do that. pH equals to minus log H plus equal to minus log 4.0 times 10 raised to the power minus 6 is equal to.
And what does that
How
give
do I
you?
get?
What does that give you?
How do I go to the minus log?
You just type in minus L, hit the minus, the little negative sign, the one in the white,
Minus.
and then hit the log button. The log button's right below the second button.
Minus log. Should I put second function?
No, don't push second function. It's just I said the log button is below the second function. Don't push second
Okay,
function.
minus log. I have minus log.
And then just type it in.
Oh, I see. Okay. 4. Oh, sorry. 4.
4.0 e negative 6. That's 4.0 second e negative
Second
6.
function e negative minus 6. Okay, got you. 5.3. 5.3979.
Well, 5.397, so 5.40. So 5.40. Now, logarithms have an interesting significant figure rule. Basically, whenever you take the log of something, the number of significant figures in your number becomes the number of places past the decimal. So it's just a coincidence that these happen to be the same number, 4040. It doesn't usually work out that way. It's just a random coincidence. But there's 2 places past the decimal, and there's 2 significant figures, so there's 2 places past the decimal. That's how you do significant figures with logarithmic values. So this is your answer. This is your answer right here, 5.40. That would be the pH of the solution.
Are you supposed to put M to it again, molarity, or just?
Nope, there's no unit. There's no unit.
No unit? Oh.
No unit. Logarithm is a unitless quantity. Even though this technically is molarity, logarithm is a unitless quantity. Now, if we're just going to do the pH of H3O+, which is what we're doing here, then it's actually a whole lot easier. All I have to do is just plug in the numbers. It's just pH is equal to the negative log of 4.7 times 10 to the negative 9. Remember, H3O plus and H plus are interchangeable. They're the same thing.
Minus log.
Negative log of 4.7 times 10 to the negative 9. You should end up with 8 point something. What do you get?
Times, hold on, times 10 raised to the power minus 9, right? 13 point.
No, that's not right.
Not right? You said minus log.
Negative log of 4.7 times 10 to the negative 9th, or 4.7 EE negative 9.
Okay, let me do it again. You said negative log. Then the second function. What am I? No, so hold on. I made a mistake. 4.
What do you get, Frank?
Negative log. Oh, goodness me. This EE is what? 22.0.
Nope.
What am I doing wrong now?
I don't know. I don't know how you're getting that now.
Minus log 4.7, right?
Yep. Second EE.
Second EE.
Minus 9.
Minus 9.
And then close parentheses, enter.
Close parentheses is equal to 30.38.
I don't know what you're doing, but that's not right.
Oh.
Are you using ln or are you using log?
Hold on a minute. Hold on a minute. Minus.
You were hitting ln, weren't you?
Minus. Look. Okay, what
Linda, I'm telling you.
Oh
my goodness.
Minus 9 equals to 38.7.
8.7?
38.
No, it's not 38.
What am I? Could you press this
Here,
thing yourself?
here,
Minus log.
I'm going to open a calculator for you. I'm going to show you how this works, okay?
Oh my
And my
goodness.
calculator doesn't work. Here, I'm going to stop sharing this. I'm going to start sharing my
You
calculator.
said minus log. Minus.
So here's how I do it on the calculator. This is how I do it on the calculator. On this cheap little calculator here. Okay. So first I'm going to put, I have to do this backwards on this calculator. You would do it normal, but I'm going to say, here, what is it? 4.7? Yeah, 4.7 times 10 to the negative 9. So 4.7 negative. And then I'm going to do, I have to do, let's see, exponents. So EE, negative 9. Oh, actually, whoops. Quit out. It's positive 4.7. The exponent's negative. 4.7 e negative 9. And then I'm going to hit the log button. Where's log? It's not ln. Log button is here. Log. Click. And negative. So it is the 8.33 is what I should get. 8.33.
Wow.
Okay. Now you would just type, for your calculator, I know how your calculator looks. You would literally type negative log 4.7 second function negative 9 close parentheses.
Let me do it again. Minus log. Minus log. 4.7 second function minus 9. It's, I don't know, it's typing nonsense from me. I don't know why it's showing this nonsense. Am I supposed to put it on scientific mode to do that?
Yeah, you probably should have it on scientific notation mode. 8, especially with these small numbers, but it shouldn't make a difference in this case. But yeah, it was 8.33.
Minus log.
Frank,
Right?
what do you think? Did you get 8.33? Is that what you got, bro? Cool.
He got it?
Mm-hmm. I'll have to maybe stay after and work with you on that. But I do want to do I do want to do one more. I do want to do this last one because this last one is a little bit tricky, especially if you're not used to logarithmic algebra. So in this case, it gives you the pH and it asks you to solve for the H3O plus. So here's what we're going to do. Once again, we are going to need to use this equation here, but
You said the answer just now was what? 8 point what? 8 point something?
33.
Okay.
8.33. All right, so, but in this case, I'm given the pH and I have to solve for the H3O plus or H plus concentration. Well, the problem with that is I have to do a little bit of logarithmic algebra. The first thing I want to do is multiply both sides by -1. If I multiply both sides by -1, that's going to give me negative pH is equal to the positive log. Okay. The second step is logarithms are very interesting. A logarithm tells you the power of something. So basically, this particular log is a base 10 logarithm. What that means is that essentially, if I want to undo this logarithm, if I want to get rid of this log, I have to raise both sides 10 to the power. So this is what that looks like. This is going to be essentially, insert an equation here, 10 to the power 10 to the power of negative pH is equal to 10 to the power of the log of H plus.
Hmm.
Now 10 to the log of anything is that thing, because 10 to the power and the log are opposite operations. It's like multiplication and division, or addition and subtraction. The opposite of a logarithm is 10 to the power. The opposite of 10 to the power is a logarithm. So these will actually cancel each other out. This cancels with this, and I'm left with H plus concentration. And so my equation here is H plus concentration is equal to 10 to the negative pH. Now, if you're not familiar with logarithmic algebra, if this is confusing, you may just want to go ahead and memorize this formula here, that H plus or H3O plus concentration is equal to 10 to the negative pH. In that case, solving this is actually pretty easy. All I have to do is plug in my pH into the formula. H plus is equal to 10 to the negative 2.39, 10 to the negative pH. The pH is 2.39, so I'll do 10 to the negative 2.39. And Linda, you can do that on your calculator very easily. You just type in 10, and then you hit that little upward arrow button, that little caret, 10 to the power.
Which caret is that?
It's a little upward arrow button. It's kind of like, it's like called a caret button. It raises it to a power. On your calculator, it's right above the x squared and right below the pi button.
Hold on 1 minute. You said I should type the second function.
No second function. No second function for this.
10 raised to the power.
10, and then the little upward arrow button. It's the fifth button down on the left side of your calculator.
1, 2, 3, 4, 1. Okay, this
the
that's
upward arrow button.
Awkward arrow button.
Yeah. You see what I'm
10
talking
raised
about?
to the power what? Minus.
So 10, that button, minus 2.39.
Okay.
What does that give you?
0.004073803.
What do you get?
0.00407.
0.004 what?
407.
407. Like that?
Mm-hmm.
Very good. That's right. And that's how you deal with these pH calculations.
Okay. It's confusing though.
So I don't think you'll be asked to do anything more complicated than that. The neutralization equations, this is just about writing and predicting products and balancing equations. We actually did this earlier in the semester, but if you need additional help with that, you can definitely reach out to me afterwards. I'm happy to go over that with you.
Which one is neutralization one?
I'm sorry?
You said neutralization, right?
Yeah, neutralization, that's the stuff that we were working on. That's the stuff up here. It's the one thing we didn't get to, but it's the same as the predicting products and balancing equation stuff that we already did. So it's not bad, but the answer key is posted. If you have any trouble with that, please feel free to stop by the SLC. Thank you so much for coming, and hope this was helpful, and y'all have a great week. See you next week.